Please introduce your presenters for leveraging technology to optimize operations. Heather Heeter is the Transportation Business Unit Leader for Borton Lawson Engineering. Heather has 20 years of transportation experience delivering large, complex projects for the Commonwealth of Pennsylvania. Her extensive background and understanding of the state and federal environmental process, transportation funding, and the complete project delivery process have attributed to her success in the transportation industry. Heather is an active ASH member as immediate past president for the East Penn section, as well as vice chair for the Lehigh Valley Chamber's Transportation Committee. Her co-presenter, Walt Stout, is the business development leader for Precise Visual Technologies, which is the group focused on digital transformation and technology within Borton Lawson Engineering. Walt has 10 plus years of mechanical engineering and technology implementation experience. This experience allows him to identify and implement appropriate technology solutions in order to optimize his client's business. Prior to joining Borton Lawson, Walt served in the United States Navy as a nuclear machinist mate on board submarines. Heather, Walt, the stage is yours.
Thank you, Ralph. I will go ahead and I will share our screen. And get started. All right.
Make sure he can see it.
Can everybody see our screen okay?
I
can see it well.
All right, thank you. All right, well, welcome and thank you for attending our presentation on leveraging technology to optimize operations. We hope that you find this presentation informative. If you have any questions after the presentation, please don't hesitate to contact Heather or myself. But why would we change? The way we've been doing things is working fine for us. I get to hear that a lot. By embracing change, leveraging technology, and utilizing a digital transformation approach, you're able to achieve your goals, oftentimes more quickly and with less effort and at a lower cost. On the screen, we have listed some of the most common benefits that our clients and our staff regularly realize from utilizing technology. Safety being first and foremost. Keep in mind that just like every project is unique, every technology solution is unique, and the primary benefit will vary greatly from project to project. When you look at these benefits, which one interests you the most? Please feel free, comment your favorite in the chat, and we could discuss it further at the end of the presentation. When we look at projects, there's rarely an overabundance of time and money. Over the course of this presentation, we'll show how you can leverage technology to optimize your operations, saving you time and money while maximizing safety and mitigating that risk. To provide a little bit of context on who we are, Borton Lawson is an ENR Top 500 full-service engineering solutions firm with national experience that is enhanced by PVT, or Precise Visual Technologies. PVT is a technology-driven group focused on providing engineering-driven virtual and visual solutions. Borton Lawson and PVT's investment and focus on connecting engineering and technology enables our teams to execute services that optimize operations within that larger digital transformation strategy. Digital transformation doesn't need to be the 800-pound gorilla in the corner of the room. Everyone knows that they need to address it, but it can be intimidating to know where to start. Technology should be a tool that saves us time and money. Our digital transformation approach is focused on optimizing your operations. This optimization frequently begins with the digitization of your assets. To describe this approach, we've created the digital transformation curve. This displays the return on digital investment, or RODI, over time as assets are digitized, modeled, accessed remotely, and used to simulate events and processes. The client's that we're working with that are realizing the long-term value in their investment when they engineer for that connected environment, rather than just seeing the design phase as a means to get to the ends of construction. Now, you or your clients could begin utilizing many of the tools that we're going to highlight today without major capital investment. However, we've seen that with a formalized digital transformation strategy, there's a much higher return on digital investment. Without that formal strategy or roadmap, it's easy to miss the solutions that will have the largest impact, or for the solutions that you roll out to go unimplemented or unutilized. Your formal strategy should be focused on your pain points. It should lay out a clear path forward by starting small, driving defined and visible return on investments, and communicating the win you can gain buy-in. Once that win has been communicated, the expansion of digital activities can be implemented. Through our own experience, we developed that digital transformation curve and an assessment tool. Based on the results of that, we've identified that the creation of the formalized digital transformation strategy or plan or roadmap is the first and most important step to take to utilize technology to optimize your operations. As we've been performing the survey and collecting data to better understand our clients and our partners' adaptation of technology and their pain points, we've identified a few key pain points. And those are multiple disconnected systems causing inefficiencies, not having accurate or reliable existing condition information, models or plans, lack of existing condition information, and that knowledge transfer. I'm sure many of you watching this presentation can relate to these pain points as you think about your business. Please comment in the chat again. What's the largest pain point that you face right now? We always work with our clients to calculate the true cost of these pain points. How much time do you spend trying to locate accurate existing condition information? How often does that occur? What happens when that senior knowledgeable employee leaves or retires? How's the wealth of their knowledge captured? Have you tried addressing these pain points in the past? Think about if you were successful. What worked? What different? It might be time for a new approach. In addition to understanding our clients' pain points more completely, we've been collecting data on a few key indicators related to how companies adapt technology and their aptitude for the integration. The first is, has your firm digitized any assets? 70% of the folks that we've talked to have. Do you have any 3D models for design, construction, operations, and maintenance? Again, about 3/4 did, which is extremely important. Many of the solutions that we're going to highlight today begin by capturing that data. Does your firm operate a centralized asset management or building management system? It's about a 50-50 split. Does your firm have a defined digital transformation strategy? If you fall in the 75% that said no, don't worry. Now is a great time to start. Is your firm's culture conducive to digital transformation? For digital transformation initiatives to be the most successful, they need to have high-level executive support. As discussed, oftentimes a pilot project can help to overcome that technology-resistant culture. And finally, did your firm use any virtual tools during the COVID-19 crisis? Most folks are gaining a lot of comfort with those virtual tools. Just look at today's conference. We wouldn't be able to get together without those virtual tools. If you're interested in finding out where your company sits on the digital transformation curve, or maybe you're just interested in contributing to our research, feel free to scan this QR code with your phone or visit the PVT website at precisevisual.com. The survey is only 7 questions long. On average, it takes less than 3 minutes to complete. All of your data is completely confidential and will never be shared. Like I mentioned, digital transformation begins with the digitizing your assets. By digitizing your assets, you're able to capitalize on many of the benefits listed on the screen. Again, ultimately saving time and money. The digitization of an asset can mean a lot of things to a lot of different people. For Borton Lawson and PVT, it's important to clarify that a digitized asset is a visual or virtual representation of that asset by either a 3D scan or a 3D model. By digitizing that asset, you move from the non-digitized to the digitized segment of the curve. As information is embedded, that digitized asset becomes intelligent, and the information can then be used to create interactive experiences in that simulated world. Now that we've covered what digital transformation means and some of the high-level benefits, I'll let Heather get into some of the case studies that showcase how the technology can really be used. Heather?
Thanks, Walt. All right, safety is and should be everybody's top priority. Our workforce is our greatest asset. Have you ever had a flat tire that had pull over on the side of the interstate? Did you feel safe? Imagine working in those conditions every day, focusing on your work while trying to stay safe. With 3D laser scanning, your employees can effectively and efficiently do their jobs without putting themselves at risk. This is a short video of the I-81 Music Bridge scan that was recently performed for PennDOT. The scan took just 1 hour to complete, and in that 1 hour, they had 17 different setups to ensure that they captured the entire underside of the structure. While Steve moves the scanner, Jim views each setup on the iPad, ensuring that the required data is accurately collected and determining where the next setup should be. As you can see, each of these setups were performed from either the shoulder of the road or behind the guide rail. Additionally, there was no need for high lifts or special equipment to obtain the accurate information. Within 1 hour, they were able to collect 490 million points of data to the accuracy of 1/18 of an inch. Our scans also come with TrueView technology that provides scalable 365-degree photos that allow you to move around, zoom in and out of your project. Each of these points, the 17 circles that you see, represent the scanner locations. This is a 3-dimensional point cloud that resulted from the field work. Being able to virtually visit the site, take measurements, and create markups with notes improves efficiency and workflow. This function is particularly useful for team meetings and discussions about a particular area of interest. Sometimes access can be a challenge to obtain survey data. For this project, we were asked to modify an earthwork stockpile, which the public felt was too high and a visual obstruction. Traditional survey would have been a substantial amount of time to complete. Therefore, we suggested to do it by drone. The drone took approximately 20 minutes of flight time. Reducing the height of the stockpile was the goal, while not modifying the overall footprint for permit reasons. Accuracy of the drone scans is dependent on the number of ground control points. The more points you have, the more accurate your scan will be. After the flight, a point cloud was created, which can be utilized for measurement purposes. The image you can see is stitched together to form an orthomosaic image, which can be geofenced for overlay onto construction drawings. Or a 3D mesh can be created as a surface of the existing features for design purposes. So for this project, that's what we did. We had a 3D mesh was created for use in the Bentley software in order to create an alternative model for the site, so we could produce volume calculations as well as contours for the plan modification. This technology is also useful for quantity verifications in construction projects or for quarries. As noted before, the accuracy of the drone flights can be improved with increased ground control points. This is a 50-acre Geisinger Hospital campus in Wilkes-Barre, Pennsylvania. 60 control points were established prior to the flight. The drone flight was completed in just 40 minutes and resulted in data that was accurate to 1/4 of an inch. Although safety, speed, and access are important, the most important thing in design is accuracy. For this project, we had a fully enclosed culvert under a borough street. The culvert has open channel sewer flowing on both sides and Monohoy Creek in the center channel. From inspection reports, we knew that the sections were comprised of multiple different structure types, and there were no as-built drawings to provide elevations or dimensions. This project was perfect for 3D laser scanning for several reasons. One, you only wanted to go into this confined space once. Two, we needed accurate and precise measurements of the existing condition since no as-built or plans were available. And three, we only wanted to get into this confined space once. Like I said, open flow sewer on either side. That's all I have to say. So control was run through the project area using Total Robotic Station through manholes to drop down control points. Utilizing harnesses and tripods along with confined space equipment, our surveyors and equipment were lowered down into the culvert to tie into the control and perform the laser scan. This section of the culvert was approximately 600 feet long. All aspects of the culvert were gathered with extreme accuracy. The data was processed in the office and combined with traditional survey that was collected topside. The scan provided millions of points inside of the culvert, giving us a full as-built, which made the design and the replacement of the superstructure feasible. The accuracy of the field measurements allowed the design of the concrete slab to maintain the existing beam seat elevations. Knowing the existing superstructure depth allowed the concrete slab to be designed and maintain the low chord elevation, aiding in our H&H analysis and obtaining the required permits. Knowing the superstructure depth also helped us maintain the existing road profile. This is important as the existing roadway grade was flat, very, very flat. The existing gutter lines had minimal curb reveal. In order to maintain that positive drainage and not impact the sidewalks and the houses, which were directly adjacent to the roadway. In addition, the accuracy of the design also allowed for more accurate quantities to be produced compared to approximations that would have been done with hand measurements. This data was also very useful for the contractor when developing his means and methods of construction with an accurate depiction of what the interior of the culvert, which he couldn't see without entering through confined space or demolishing the top portion of the structure. For another project, the Pennsylvania Turnpike advertised a project that included a 55-hour closure weekend to complete the full superstructure replacement. The design had to fit within the existing abutments for the closure window to work. The contractor faced liquidated damages of $55,000 an hour, and they sustained these for any hour beyond the 55-hour window. Scanning of the existing bridge abutments and beam seats was key to establishing the accurate existing condition so that the replacement structure could be craned into place without incident. And I wanted to note, we opened a half hour before our 55 hours. Moving on, this is an actual photo of a stone arch in Monroe County, Pennsylvania. This is a point cloud of that same structure. In an effort to preserve the architectural significance and history of the existing structure, the state decided to rehab the stone arch culvert. The design began with a 3D laser scan. From the scan of the structure, we were able to create a highly precise model, which we were able to capture all applicable dimensions of the structure. The model was then utilized to design and fabricate fitted steel arch liners that will significantly improve the structural capacity of the stone arch and remove the structural deficiency rating. The design and the detailing of the repointing of the stone spandrel walls and the repairs to the structure are easily defined and tabulated due to the preciseness of the scan. On this stone arch, the spandrel walls have been bulging in different directions and severity for quite some time. Our field crew collected data from 25 different locations in just one day. The heat map that you see here was produced to show the areas that were bulging more than others. Color changes are set to 1-inch increments. The areas in green represent 0, and the deep red represent areas of greater than 10 inches. The areas of concern, tighter increments can be shown when zoomed in, and measurements are accurate to 1/8 of an inch. By scanning and producing a heat map, we save time, measurements are accurate, and the location of the bulging areas of concern are easily and precisely pinpointed. This is a short demo video of a scan that was done on a 660-foot long linear section of Spring Creek for a virtual field meeting with DEP, Army Corps, PA Fish and Boat, and the Conservation District. Similar to Google Earth, you can reach different segments by clicking on the next data point. Each of the points you see here are setup locations. As you can see, similar to the Music Bridge scan, we have 365-degree views of the existing stream channel. The TrueView software allows for spot measurements, such as lengths, widths, angles, and will even give you latitude and longitude locations of each point for precise location identification. This technology is very handy for the world we're living in today, but in a post-pandemic world, it can be very useful as well. How long does it take you to get multiple agencies to set up a calendar appointment for a field view? This technology allows you to visit the site from your office or home with no travel time. So if a picture is worth 1,000 words, then I say a video is worth 1.8 million. Making our client's vision a reality. This interstate reconstruction project included the reconfiguration of several ramp movements at this high volume interchange. By developing a 3D rendering, you're able to help your clients and project stakeholders who are not familiar with viewing two-dimensional engineering drawings. This rendering was put together using Concept Station to develop a 3D fly-through of the project. The 3D software does not only create pretty pictures, but is a construction-driven engineering tool that helps designers refine best practices and integrated 3D conflict analysis tools for accuracy and decreases unintended errors and omissions to save time and reduce construction work orders. This will enable you to review plans in 3D to easily identify inconsistencies. You can also review clash detection in 3D or table format, and helps you with the ripple effect when changes are made during the design process. So an engineer designed it, a precaster made it, but can you get it to the site? Delivering and maneuvering large pieces of equipment or precast elements can sometimes be a challenge. We can create 3D models of equipment and bridge elements to virtually transport equipment and materials to a construction site. This helps validate the best haul path and identify any interferences that you might have. Now, on the next slide, please pay particular attention to the iPad. Virtual constructability. This identifies conflicts in the design and the existing condition. By checking for clash detection, it allows for seamless assembly. This is particularly useful when you have tight construction constraints like we have here. Thank you. This concludes our presentation, and we would be happy to answer any questions that you may have.
Thank you, Walt and Heather, for that great presentation. I'm Amanda Schumacher. I'm also with Borton Lawson, and I'm going to be your Q&A facilitator today. It looks like we have one question here that was posted. Were control points set using panels or by just using photo identifiable points in the images for the drone missions?
So we establish control points using survey grade controls. We have several different drone pilots that are all licensed here. and we do go out and set survey grade control. So that's on top of any photo identifiable points.
Okay. I do encourage you to please post any additional questions you have for Heather or Walt. And I know, Jim, you posted originally in the chat and then you put it in the Q&A, so thank you for that. But if there are any other questions, please feel free to ask now. I do have a couple that, that I could ask while we're waiting for additional. Is there a way to measure, there was a lot of mention of cost and time savings. So is there a way to measure that time and cost savings by using these technologies?
Absolutely, and working with our clients to determine what that return on digital investment is something that we're very comfortable and experienced with. That being said, it varies greatly from project to project. You really have to sit down and look at what assets you're digitizing, how you plan on accessing them, what the traditional means would be, and where you can get additional value, leveraging those digitized assets in other areas to really perform that calculation. If there's a specific use case that you have, I'd love to sit down and discuss it further, but they're so project specific that you really have to have a deeper discussion on that to determine what that return on digital investment is.
Makes a lot of sense there. There was another question here that we are looking for augmented reality platforms, technology, and PA, but are having trouble finding the augmented reality software. Do you have any recommendations?
Augmented reality, it's really the future when it comes to the operators and working in the field. We see that as a big technology advancement that's on the horizon. It's something that we're pursuing ourselves. If you have more specifics on what you've looked into or what the specific application is, we might have some opportunity to have a discussion on where we see the technology working and what companies we've seen that provide those softwares.
Perfect. Yeah, I don't know if you can see here, see the chat, Walt, but so you can see who posted that. Jason Zhang posted that question. So maybe you guys can meet up in the lobby and kind of talk a little bit more after the session. Some more questions coming in here. Was DOT and the public pleased with the historic presentation of the stone arches?
Yeah, we've had a lot of success, especially with the public, with the preservation of the stone arches. Stone arches are one of those things that the public feels very tied to and connected to, but aren't always historic. So during the process, you kind of have to just figure out if they are on the National Registry, if they're listed, or they're a contributing element. So what you can do with the stone arches varies on those. So we have done numerous stone arch renovations, some with the arch liners, some without, but people feel very tied to them and really do not want them to go away and replaced by a big concrete bridge. So we have found the arch liners are great for the arches that are not technically considered historic or not on the National Registry, but we have also done other preservation where we unload the whole arch, fix the elements, and reload it and truly preserve that arch. Those are for the ones that are a contributing element to maybe a historic district or structure. But yeah, the public, that's usually what they come to the public meeting saying, please don't tear down this stone arch. We really like it.
Great. Another one, is there any technology you guys are currently research and developing or investigating that wasn't presented today?
So absolutely there is. That can get into
all the secrets, Walt. No, just
right. I would say a lot of the technology that we're investigating right now or performing R&D on is centered around remote evaluations, remote inspections, as well as giving some of the higher level folks easy access to information that's required for key decision making. Maybe it doesn't have all the nuts and bolts. They may not be able to get all the information they need to do a design, but giving some of those senior, more executive level people the information that they need in an easy to use format.
Great. So are there any processing issues with hardware using the concept station to create the 3D renderings? In other words, do you have beefy computers running the software?
So yes, absolutely. For the data processing and for the point cloud registration and the stitching together, the computers are pretty impressive. They're much more powerful than the laptop or the typical desktop PC that you might have. That being said, to utilize the output, to utilize some of the point clouds or the imagery, you are able to do that on a relatively lightweight computer, whether that be local to a network or over the cloud.
And a lot of times what we find is, our guys will input the design and have it run overnight. So a lot of times in the morning, they come back in and they're able to use it. So I know with the 3D rendering that you saw for the I-78 project, that's what we did. Josh would kind of put everything in, and then he would almost like batch it overnight. I'm sure I'm not using the right word. But then by the time he came back in the morning, it was either almost done or it was completed and he was able to move on with it.
Great. And have you found that private clients or public clients are more willing to invest in the technology?
Wow, that's an interesting question. I think that we've found that there's good application in both. It's really centered around what the pain point is and how that pain point is addressed or lessened, that we found is really the key indicator of the adaptation of technology, much greater than if it's a private or public entity.
And I mean, the technology, especially with COVID, I think a lot of people are really pushing forward with that technology envelope than they have, more so. So even on the public side, with PennDOT and the Turnpike, I really feel like they are really utilizing transportation and the technology so much more than they have in the past couple years, and are more open to the conversation of, look, we have a way that's a little different to do this. We could do this survey with drones and we can stitch it together with traditional survey. They're moving out of that comfort zone of, but this is the way we've always done it, and into that digital delivery effort. So.
Absolutely. Good points. How do you manage the vast amounts of data? So I guess going along with those beefy computer questions in terms of processing, but how do you manage the vast amounts of data? Do you have software that reduces the quote unquote noise? And do you use additional hardware to be able to use it?
So we do use softwares to reduce the noise being non-pertinent information in the point cloud. So we will slim down those point clouds pretty significantly to just focus on the project scope. One of the biggest, technology advances that we could discuss for managing that vast amounts of data is the cloud, both processing and storage. In addition to making the softwares run a little bit faster, it also provides that really critical remote access to that information. That way you don't have to be in a specific location to get the information you need. You can get it wherever you can get access.
Great.
But as far as additional softwares or hardwares,
hardwares, yeah.
Most of that from the software side is provided when we do a project. We try not to burden anybody with buying a new license or a new software. And the hardware, I would say, is nothing more than the computer on the user end. For us, performing work, the hardware investment is very significant.
Got it. One other question is so bathymetric survey by drone or sonar for bridge inspections. Is that something that you're looking into to do either by drone with traditional 3D scan setups for scour debris inspection?
So underwater bathymetric surveys are something that we are looking into. We have some experience. It's a field that's greatly growing right now. I'd say that that's something that we're looking for more opportunities to pursue, and it's a technology that's really advancing right now.
And we just actually won a project that we are looking at doing that, not so much for bridge inspection, but we have miles of noise walls and retaining walls along a project, and to really inspect that backside where access is an issue, we're looking into the possibility of using drones to do the inspection of the backside of the noise walls. And that way you can just pinpoint areas that maybe you will have to go visit out in the field, if they arise, or, you may be able to see everything and say, okay, this is good. And, because the accuracy is there and we're really able to get that and do it in a more efficient manner.
Great. Last question, it looks like, do you have any experience with hydrographic surveying applications?
So I would, again, that kind of falls into that same category as the last discussion.
Yep.
Yes, we do have some experience, and we're always looking to grow that into a bigger level of experience.
Okay. Well, it looks like that is the end of the presentation, or the end of the questions, I should say. Give you one last chance here to ask your final questions. I have one final parting one, and then we can close the session here in terms of how is this helpful, or the technologies helpful in each of the phases of a project. So planning, design, and construction. Just quick highlight items, maybe key areas of use.
I mean, it's so applicable. It really is what you're looking for in the planning stages, especially if you're talking corridor type projects. It really is able to, one, gives you the visuals, but also, an accuracy to a certain magnitude for planning purposes. So we had that drone survey of the campus that we did for Geisinger, and that was for some building expansion work and things that they were planning. So that was more in the planning stages. In design, a house is only as stable as its foundation, and using these technologies, for getting that survey, that upfront survey is just so important for building your design model. So, if you start with, a high quality base survey, you can build from there. But if you, start with some survey from here and here, and you piece it together, you're not starting from a solid foundation. So as your design grows, sometimes you have to go back, take steps back, and redesign certain areas. So similar to building a house, starting with that solid foundation. And then in construction, the drone stuff for progress meetings, quantity verifications, there's so many different things, the virtual constructability reviews, that it's really endless possibilities. And that's why the conversation is so important of, okay, we have this technology, but what is it you need to do, and how do we think we can incorporate those technologies to help you do that job better or more efficiently?
And then I would just couple onto that there are applications in every phase of the project, including operations and maintenance. A lot of times the value, that additional return on digital investment, we stop looking at it once we get to the end of the construction phase. But really, health, safety, environmental, project management, even HR or marketing can use all of these digitized assets for better visual and virtual representations of the assets and communication. It really brings down some of the barriers to communication. And
in the facilities, you guys have done extreme amounts of technology with this for asset management. And absolutely. Loading in tags with manuals.
Providing that easy access to your critical asset information, as well as for virtual construction, monitoring the progress. You can take a series of scans or a series of drone flights, compare them side by side, or even overlay them on top of each other. That way you can see what's changed. Is it being built according to specifications? Are we getting the proper quantities? There's a lot of great tools that you can optimize and even, program out, so it's very little effort.
Great. Well, thanks so much. I'm hoping you guys can see that chat because you're getting some good comments about the presentation. Thanks so much. Oh, good.